Hello everybody, you probably know this guy here. His name's Mike Fudge. He's your IST256 professor. You know who you don't know? Me. I'm Ekim Egduf. I am Java student extraordinaire, and today I'm going to show you how you can use GitHub to submit your problem sets. Alright, let's get going. So the first thing you want to do is you go to the GitHub website, and by now you should already have an account. I have an account, and I'm going to sign in with my username and password. And when your professor, Fudge, is ready to give you work, he will put a repository in your account. So what happens is you won't find the repository under your default account because that's what you control. It's under the IST256 organization. So under your name, if you go to IST256, in there, you will see one of the repositories that he pushed to you. For example, you should see one that has your name and then problem set 0. This corresponds to the extra credit repository that he promised you. This repository is really just a way to get you warmed up with the workflow required to submit work via GitHub. I think you'll find that this is pretty cool. So I clicked on that repository, and always you'll see a README, and the README will have a basic set of instructions for you to follow for the assignment, and it'll give you a well-rounded idea of what the work you need to do is all about. The way these GitHub repositories work is you think of them as a folder, and inside the folder are files and other folders, but these files and folders are stored in the cloud, and you need to have a way to get these files from the GitHub website down to your computer so that you can work on the code. The easiest way to do that is with the GitHub client. So what we're going to do now is we're going to download and install the GitHub client so that we can connect the client to this repository. And you'll see this is pretty easy stuff to do. So the easiest way to do it, if you have a Mac or Windows, just go to Clone in Desktop, click there. This also works in the lab. I'm in the lab right now. Now, if for some reason clicking this button doesn't do anything, like is happening with me, you'll have to go download the client manually, and it's pretty easy to do. If you have a Windows computer, you go to windows.github.com. If you have a Mac, you go to mac.github.com, and you click this button, Download GitHub for Mac or Download GitHub for Windows. This will bring up a setup file, which you can then run. This should install in the labs. It's going to download the rest of it. Just click Install here. When the GitHub client is downloaded, you'll see an icon on your desktop, GitHub. You can open that up. It'll launch the GitHub client. You'll have to set it up for the first time. I'm going to put in my username and password. This is my GitHub information. Then you should set up your configuration. This should be your name and then your email address. And now you should be able to add the repository. And it's pretty easy to do. You go up here. Now, one thing that you probably want to do is configure GitHub under Options. And one thing that you probably want to set is where is the location of where the files get cloned. Okay, so this is where you have to decide the code that gets copied off of GitHub, where is it going to live locally. I'm going to put that in H classes, because I have a folder called classes, IST256. I'll do that. And now I'm going to clone that repository. So cloning is copying the repository from the GitHub cloud down to your local computer. And it'll ask you where you want to put it. I'm just going to hit OK here. And now again, it's copying all of the assignment files that you need to complete this problem set to your local computer. Now what you'll notice GitHub has is what's called a history, and the way source code control works is you do some work, then you commit that work and you put a message to it, and then source code control will track all of the changes that you made. And so you can see, here's a look at the instructions page that you saw on the website. here, but now you see a different rendition of that instruction page. You see a different rendition of that instruction page where it shows you the differences between what I did, what your teacher did 30 minutes ago and what your teacher did an hour ago. So an hour ago it looked like that, and then it was changed 30 minutes ago to look like that. So the beauty of source code control is that you can see how your code changes over time. So as your professor looks at your assignment that you hand in, he will be able to see how you worked at it over time, which is important to understanding, where you're struggling and in your efforts to complete the work. So this is critical. So one thing that Professor Fudge will tell you to do is commit your work often. Every time you sit down and do your work, when you're done, save it and then commit it. You don't have to necessarily push it up to GitHub, but you should at least save it and commit it so that it's storing a history of the changes that you're making. All right, it's time to do some work. So what the instructions are telling me to do here on the website: clone the repository. I did that. Now answer the questions in the assignment file. So it says, from the GitHub client, open the repository in Explorer. So one of the things that you can do is you obviously can't edit the files from here. So what you need to do is you right click over here and go open in Explorer. And that just gives you a folder. And this takes you to where you created or cloned that repository. It's just on my H drive, like I said. And now I can actually edit these files. And so when you're doing this with real problem sets, problem set 2, 3, 4, 5, etc., what you'll be doing is opening these up in NetBeans and working on them. But for now, what I'm going to do is I'm going to take this assignment, I'm going to edit it, and I'm going to answer these questions. My name is Ekim, and my address is that. And my professor's name is Fudge, and we're going to learn Java programming. So I'm going to answer those questions. I'm going to save the file. Okay. Then the next thing that the assignment tells me to do, answer the questions. When you're done, save the file. From the GitHub client, commit your changes as step 1 answered questions. So I'm going to do that now. So if I go back to the GitHub client, it now has these uncommitted changes. Uncommitted changes means you have edited the files in the source code repository, but you have not committed them as a change set. So I'm going to do that now. Step 1 answered questions. I could be more descriptive here. Usually when you're doing this for a real assignment, you'll probably say something like, I worked on part 1 and completed most of the methods and classes, or something like that. And if you have trouble, you might say, I got really frustrated. It didn't work as I expected. You can put all that stuff in here. Like, this was really easy. Give me a challenge. So what you do is you hit commit to master. That saves it locally, but it hasn't synced it up with GitHub yet. We're not going to do that right away. We're just going to commit it for now. You could sync this up with GitHub if you want, to have a copy of it placed in the cloud, but you don't necessarily have to do that every time you commit. It's a good idea to commit often, but it's not really necessary to always push your changes up to GitHub every time you commit. It's really a matter of preference. One thing is for sure is you need to make sure you do push all of your changes up to GitHub before the assignment is due. So by the due date, you got to make sure you submit your work. Okay, so up here it says this branch is ahead by 1 commit, and then that's what the 1 and the arrow mean up here in the corner. Let's move on to step 2. Step 2 says create a brief bio. From the GitHub client, open the repository in Explorer. Create a new text file called biotext in the same folder as assignment text. Okay. Here's my folder, new text document, bio. Now I'm going to open it up. And what do I need to do here? Write 1-sentence biography about yourself. Save the file. My name is Ekim, the alter ego of Mike. Okay, that's good. Save it up. Then I need to commit that change as step 2 my bio. So I'm going to make another committed change, step 2 my bio. Again, the rule of thumb here, this is a comment. The rule of thumb here is that every time you do work on your problem set, you're probably going to work on the problem set not in one sitting, but over time. And as you work on it, piece by piece, you'll do your work, and then when you're done, you'll commit your changes. Do more work, commit more changes. When you need to back it up, you can then sync it up with the server. Or when you're ready to hand it in, you definitely need to sync it up with the server. You click the sync button up here. It will take the changes that you made locally and then push them up in the cloud to GitHub. You can see what's going to happen. After you push your work up to the cloud, I pull down your work. Oh, I'm sorry, I don't pull it down. Professor Fudge pulls it down. He grades it and then pushes it back to you so that you can see in the change set how your work was graded. Okay, so it looks like everything has been synced up, and you can see picture. This is why it's important to put pictures in GitHub. See, this is the professor's picture, and these are my pictures. So you can see which changes were made by you and which changes were made by the professor. And you can see now this is what it looked like in change set 37 minutes ago, and 3 minutes ago I added these answers. You can clearly see the answers added because they're in green. And then I added a new file with the bio in it. Cool. Now what's neat is, what does this look like on GitHub? This is where the real power of using this for managing source code comes into play. First thing that you'll see is if I refresh this page, just going to reload the page, I can see now that bio text is up there. And if I pick on any one of these files, like assignment text, I can look at the history and see how it changed. So there's what it looks like when Ekim got a hold of it, and there's what it looks like when it was created by Professor Fudge. Kind of neat. So the other thing that you could do is you can get some analytics on what's happening here. So if you go to graphs, and this is a really kind of neat one, if I go to commits, I can see that there were 4 commits today, 2 by the professor and 2 by me. If I go to punch card, I can see there was 1 commit there, and there was 2 commits here. There's 1 commit there. So this will give you an idea of how you worked over time. This will tell you who did the commit. So the student, me, I did 2 commits, and the professor did 2 commits. So let's wait for the professor to grade our work, and then let's see what the GitHub client looks like when that happens. For now, what I'm going to do is I'm going to close out of the GitHub client. I'm just going to stay here on the GitHub web page, and we'll pretend like we're just going to come back after the professor grades our work. Be right back. Okay, some time has elapsed, and the professor has graded the work, and the way I know that is there's 1 more commit now, and the last person to commit was the professor and not me. And if I go look at the 5 commits, this commit message says graded your work. See, the original 2 commit message were making the assignment. This is the one that I did where I answered the questions. This is the next one where I did the bio, and then this is the professor's commit where he graded my work. I can click on that, and now I can easily see the professor's comment. See, so this is the assignment text file, and I can see where the professor added this comment. That's Michael Fudge to you, Bub, not Fudge. And then here's my score, 4 out of 4, bravo. And then down here in bio text, there was a comment added that says, what an intriguing bio, well done. Pretty cool. So it's very easy to see the professor's comments in line with your work thanks to source code control. Your professor can also correct some of your mistakes this way as well. If I go and look at the actual bio file, right, I will not see the changes that were made yet because I haven't pulled them down in the GitHub client. Remember, I was looking at the GitHub site. So the website is actually ahead of what I have on the client. So if I launch the GitHub client and select the repository for problem set 0, it's syncing now. And it will tell me that the cloud version of GitHub is 1 version ahead of my local repository. And so if I click this button, it will pull down the professor's changes to my local computer. Again, do you have to do this? No, but it's useful to do this if you want to actually try to run some of the corrections that your professor makes. You can certainly just see on the website the corrections that your professor made, and they'll also be posted in Canvas. But if you want to actually run those changes, you might want to pull down the local repository. So now I'm up to date. I have graded your work locally, just like it's graded your work in the cloud. Now when I open up bio, the comment is there. What I don't see is what I wrote versus what the professor wrote. The only way to see that is to look at the diff inside of Git. See that? So that will show me what the professor wrote versus what I wrote. If I actually look at the real files, all I see are the end result. And that's the important thing to recognize about how the way source code control works is you shouldn't see any source code control stuff in the actual files. You're just going to see the state of the file at the time that it was changed. If you want to track how it looked over time, you have to use the GitHub client or the GitHub website, one or the other, to do that. Hopefully that introduces you to GitHub and how we will use GitHub to submit our work in the IST256 class. For extra credit, you need to complete exactly what I showed you in this video. So go have at it, and good luck to you all. If you have questions, please feel free to ask the professor. Thank you. Have a nice day.